This is Chapter 5, Section 3, Dividing Polynomials. Okay? Now, when we're dividing polynomials, there's a couple different things. First of all, you could be dividing a polynomial by a monomial. You could also be taking a polynomial and dividing it by another polynomial. So, two different things we're going to take a look at. The first one would be dividing a polynomial, many parts, by a monomial, just one part. But before we even look at that, I want to remind you a little something about fractions. Okay? If you were going to add two fractions that have like bases, this is not new. You should all know that you add the numerators and the denominator comes together because it's 2/3 and 1/3. Yeah. So put it together, that's 2 plus 1, which makes 3/3. And then you reduce it and it can be 1. So knowing that, it should make sense that it can be reversed. Okay, like I said, this is not new. This is way, way, way back when you first learned to add fractions. This also makes sense then, I hope. 4 plus 5 over 7 equals 4/7 plus 5/7. Does that part make sense? Okay, so I haven't changed the value here and here. Okay, it's another way of writing the same thing. Now, when we divide polynomials, we're going to use that same concept, that you really have two fractions added together when you have a sum over a single number, in this case, a single monomial. Okay? Here is an example problem. Okay? We have a polynomial. Okay, this one happens to be a trinomial divided by a monomial. So let's make sure everybody can get this problem written down. 6x squared a plus 3xa squared minus 9x squared a, all divided by 3xa. Okay, let's get everybody have the problem written down. Okay, notice we have things that are added together and a little subtraction, just like up here. So that means that I can break this down into how many problems how many different pieces do you think? Three pieces. And they're all going to have what for a denominator?
3xa.
3xa. Just like this one had a 7, and they both were 7s, this is going to be 3xa. So I really have 3 smaller problems to simplify. So I have 6x squared a squared over 3xa plus 3xa squared over 3xa, and then we have a minus, okay, because there's a minus here, we have a minus here. Once again, 3xa on the bottom. And then the numerator, we have 9x squared a. So now we just have 3 problems that we can simplify like you did when you divided monomial by monomial in the other section. Do you have a question, Antonia?
Yeah, do you have to write it that way, the second one? Like equals that?
Do you have to, you don't have to expand it like this. If you are able to just divide each one, just make sure that if you start canceling things out, you don't leave it like this. Because if you start actually drawing the cancel out parts, you'll confuse yourself because there really are 3 separate pieces to it. Okay, so let's look at this one first. Okay, this one, we're really taking 6 divided by 3, which gives us 2. X. Because there's 2 x's in the top, 1 in the bottom. Subtract the exponents, x is in the top. And a squared over a gives you a. Okay? 2 minus 1 gives you 1. There is no denominator. It divided out nicely in that. And then I put in a plus.
Excellent.
3's cancel out. 3 over 3 is 1. Do we have any x's left?
No.
No, because the x's also cancel out. Do we have any a's left?
Yes.
1a. Okay? Because a squared, a, you've got 2 up here, 1 down here, 1 set will cancel, you're left with 1. Then we have minus 9 and 3 gives you 3 when you divide them. You have 1x and no a's because a, anything over itself cancels out. So my final polynomial is this. There's no like terms to combine because they have to have all the same variables. This has an xa, this has an a, this has an x. So you can't put them together. So this is your final answer right here. So when you have a polynomial divided by a monomial, you need to really think about it as being 3 little mini problems. Okay, and take it like that. Expanding this is a really good idea if you tend to find yourself getting confused. Okay, even if you don't tend to find yourself getting confused, if you even find yourself getting one of them incorrect on your practicing, then you need to write it out because you need to make sure that you practice the right work instead of the wrong work. Okay, all right. There, anybody still writing that? No. Okay, let's move on. Now here's an interesting thing you might have thought that you were past and never had to see again. Long division. Okay, you remember long division.
Beautiful.
Okay? Remember long division back from the days when you'd have to divide 32,586 divided by 23? You had to set up the big fraction bar. Well, it hasn't gone away. Okay, long division can work with polynomials. This is why you needed to learn how to do that. Okay? Breaking this down into 3 parts isn't really going to help us. This is a difference. Okay? It's not a product, so I can't cancel things out. I can't cancel the c's out. I can't cancel these 2 things out. Doesn't work like that. So breaking it up like we did the last problem will not help you.
What?
Okay? But what you can do is set it up like a long division problem. And we're going to have actually two methods to solve this, but this is the first one. It's not too difficult. This is our divisor. It's the dividend divided by the divisor. So you set it up like this, just like you did way back when you did long division a long time ago. Okay? And if it has been since 3rd grade, then you should have gotten really good at it back then, and it should come back very easily. Okay, so the numerator goes underneath the division sign. This polynomial, this is a binomial, goes on the outside. Okay, now, don't pay too much attention to this second part of your binomial. But what you do want to do is you want to look at this part of your binomial. And just like when you were using numbers, you want to say what number or what variable times this gives you this first piece. So what times c gives you c squared? C. Okay? So I'm going to put c. I'm going to use it like place values. See how we've got the c squared column? We also have a c column. So I'm going to put this c right over this c because I'm thinking of it just like place values. Now, when you were doing long division the old way, what would you do next after you figured out what number went up here?
You
Multiply it times this one, right? Everybody look up.
What?
You're going to take this number here, multiply it
Oh yeah.
by this. So what do I get when I have c times c minus 6?
C
squared
minus 6c.
Minus 6c. Okay? C times C is C squared. And here I have C squared minus 6C. So now, this right here, if I need to subtract these, okay, remember you're subtracting these. So when I subtract them, what happens to the signs? They get switched. So since you're subtracting, you might want to go through, change your signs so that when you go down the columns, it's going to make sense. Okay? If you had a colored pencil or another pen or something, it might help you to see it. Or you can go back and look at this when you get home online. Because you're subtracting. So you change the signs and then add. It's going to help you keep track of what's going on a little bit more easily. All right, so C squared minus C squared gives you 0. What is negative C plus 6C?
5C.
So positive 5C. And what did you do next when you were doing long division back in the day?
Bring down that number.
Bring down the other number. So we bring down the 30. Long time ago. All right, now, when you were doing long division in the past, what would you do next?
Divide it, maybe.
See how many times this goes into this one, right?
5.
So what times C gives you this?
5.
5. Now once again, we're going to put it in the right place, but we have to put a plus in between. So now we have a combination of variables and numbers. Why a plus?
Oh, I see.
Because 5 times C gives you 5C. It would be a minus if this were a minus 5. Okay, so we do 5C. 5 times C is 5C. 5 times 6 is 30. Minus 30. And when you subtract them, what we get is 0, which is very convenient. It means that C minus 6 went evenly into C squared minus C minus 30. So my answer is C plus 5. And that's it. That's the answer. Now, in order to check your division problem, you could multiply, right? So in order to check to make sure you're right, you would take this times this to make sure you get this. Okay? Remember when you divided something and it was plain numbers, you would multiply the things that you got times the divisor and then make sure that you got the dividend. So let's do a check here just so that you know how to check it. In order to check it, we need to take C minus 6 times C plus 5 just to make sure that we get C squared minus C minus 30. So,
This looks different.
well, do you remember how to do that? Just from yesterday. FOIL, right?
I wasn't here.
So, first terms, C times C gives C squared. So, remember we're actually distributing each thing in the first term to each thing in the second. Antonia?
Oh, I was asking is there a way to set that up vertically too? Like C minus 6?
You can, but I don't want you to. Okay, I'm just, it's going to make it, if you're always doing it vertically, it's just going to make it more difficult. So first, outer, that gives you plus 5C, right? Inner, then we're going to take this negative 6 and distribute it to both places. Negative 6 times C is negative 6C. And the lasts, negative 6 times 5 is negative 30. Then put the like terms together and we get C squared minus C minus 30. And that checks out because it matches. Okay, so that's good. So this tells us that you did a good job and we actually got the right answer. Okay? Yes.
How How did we get the 5c minus 30, the second one? How did you get that, like, again?
5 times c minus 6. This 5 has to get multiplied times these,
Alright, okay.
this number, and then it gets brought down here.
Alright.
Okay. Now some of you, it may have been a while since you did long division.
Oh yeah. It's been
Okay.
years.
But hopefully it comes back quickly, because now we need to use it in polynomials,
Okay.
and there really was a reason for you to have learned that in elementary school. This is not something your calculator is going to do for you.
Oh, wow.
You can't put the polynomial in, divided by the other polynomial, and have it give you a polynomial. It just doesn't do that for you. So you have to be able to do this. Okay? Dividing it out and finding an answer. Okay, let's check on another one that comes out with a remainder. This one has no remainder. So that's all good. Now this one I don't think will have an, this is supposed to be an X, so let me change that. Let me fix that one. Eraser. This is meant to be an X. Sorry about that.
It's okay.
Okay, now this one actually is a division problem, but it doesn't look like one. Okay? Who can tell me why, how is it that this is really a division problem? Antonia, what do you think?
Because there was a -1 times 6 minus x.
Good. This -1, this exponent, means that this whole binomial belongs in the denominator. Okay, so this is really a division problem, but it doesn't look like one. So let's rewrite it in its division problem form, first of all. But I write it like that because in the homework and whatnot, you might encounter something like this with a negative exponent. So we're going to do this. Okay, now, the other thing that's going to make this problem a little bit more challenging is this is not written in a way that we like to see it. And actually, in order to do this problem, we should make this so that we have the x part first and the 6 part second. So I'm going to rewrite this once again. Before this part stays good up here. And then this becomes negative x plus 6. Does everybody see what just happened? Okay. All we did was switch the order, but since the negative was attached to the x, it has to come with it over here. Alright, so what we need to do is set this up as a long division problem. Okay? What goes on the outside of this thing here?
Negative x plus 6.
Negative x plus 6 goes out here. And inside goes,
X squared plus 4x minus 6.
good, x squared plus 4x minus 16. Alright, so we have our division or long division problem set up. So we have to go through and start thinking, what times this is going to give us this first number? What times negative x is going to give you x squared?
Negative x.
Negative x. Or the opposite of x, I should say correctly. So the opposite of x times the opposite of x gives you x squared. Okay, now what do we do?
Bring it down.
Bring what down?
Negative x plus 6.
Negative x times negative x plus 6. Don't forget to multiply these two first. So what is opposite of x times opposite of x?
X squared.
X squared. What is opposite of x times 6?
Negative 6.
Negative 6x. Okay? Now before we put these things together, what did I tell you to do?
Change the signs.
Change the signs to make it easier to look at and easier not to make a mistake. Because you're really subtracting them. Okay, now we put these together. This x squared minus x squared is 0. 4 and 6 gives us
10.
10x. Then we do
Bring down negative 16.
bring down negative 16. Okay, and then we have
10x minus 16.
10x minus 16. So how do I figure out what comes next up here?
No,
Negative.
what goes into that? What goes
Negative.
into
It's
10x?
negative something.
It's negative something.
Negative.
Negative what times
10.
negative x gives you 10x?
Yeah, there you go. Good job.
Negative 10. Okay? So then we need to multiply this negative 10 times each of these. So negative 10 times negative x gives us 10x.
Minus 16.
Now, negative 10 times 6 gives us
Negative 10x, negative 16.
negative, it's times
Negative 60.
60.
Yeah.
Okay, they kind of fooled you. They wanted you to make a mistake. They put with this particular example. Negative 10 times 6 is negative 60. Now, it doesn't all completely cancel out, so I should change my signs. Okay? I change my signs. 10 minus 10 is 0, so that's done. But I have a number left over. Okay? 60 minus 16 is
54.
54?
Yeah, I think so.
Yeah, 54.
Are you sure?
44. Now it's 44.
How about 44?
Yeah, it's
Who said 54? I did.
Couple people.
Bro, it's 40.
It's very easy to do that because you subtract here and then forget that
Yes.
you had to
She said it
borrow.
could be complicated.
But 44, now, this is a different type of answer, isn't it? We have a remainder here.
Yeah.
Do you remember what did you do with a remainder?
You put it on the decimal. You make it a fraction.
Make it disappear.
You made it into
Okay.
a fraction. So what if we have negative x minus 10 plus 44 over what? What we're going
Negative
with?
plus 6.
Negative x plus 6.
Oh. Yeah, 'cause, okay, you said a little fraction.
That is nasty.
Okay, it's the remainder over the divisor. Here's our divisor. So you put remainder over divisor.
Boom, boom, boom.
Nasty.
Hmm? Okay, it's a very, very strange looking answer, but that's how your answer comes out. That's why you should make sure that you can always do that. Charles?
Yeah, I got everything else. But if it's 4x minus 6x, wouldn't it be negative 2x?
But you had to change the signs.
What?
Negative times negative made positive. Negative times positive made negative, but then you have to change the signs because you're actually subtracting them.
So I'm subtracting 4x minus 6x.
So you're taking 4x minus negative 6x,
Okay.
which is why I changed to a plus.
Uh-huh.
Okay, so you have to change the signs, okay, before you put the columns together. Okay, it's, if we go back to the other one, same thing happened, okay? You got c, this would be c squared minus 6c, but then we had to change the signs and then add, okay? The weird thing about this one is because we got the positive, then we got the negative, then we changed the signs, but our mind doesn't like that we have a remainder, okay? And then the minus 16, and then this messes with us too, because we're seeing 16, but it's really not, it's 10 times 6. Okay, so we just have to be extra careful on that, okay? Alright, let's do another one. It can be a 4-part. Now, as we notice, these things get more complicated as we go. We are going to be working on getting a shortcut called synthetic division.
Yes.
But for right now, we're going to still do this the long way.
Whoa.
And we're going to divide this out,
Sounds like fake division.
and we're going to take x minus 3. It does sound like fake division, synthetic, but it's not fake. It's actually a really neat shortcut, and you're going to love it.
Yay.
Okay, we like shortcuts.
Shortcuts are awesome.
6x cubed minus 19x squared. The only problem with it is that you have to remember the steps, and sometimes if you forget the steps, then
No,
Ew, this is a
you get
nasty one.
confused.
They're all nasty.
Alright,
Yeah.
so we've got all these things. We got it set up now so that we can do long division. And we can ask, what times x gives 6x cubed?
Ew. 6x
6x squared. So 6x squared times x gives 6x cubed. But then 6x squared has to be multiplied times negative 3 also. And that gives us
Negative 18x squared.
negative 18x squared. Put a line underneath. But we're subtracting, so I have to
Change signs.
change the signs.
Oh, we only did
That's the hardest part, is remembering to change those signs. So then we go down and you subtract and you get
negative x squared.
negative 1x squared. And we need to then
Bring down
X.
bring down the x.
Look at that.
Okay? Now this is the first time we're not just doing it in like one step. We have another step to go after this. So what times x gives you negative x squared?
Negative x.
Negative x.
No.
So negative x times x is negative x squared. Negative x times negative 3 is
3x.
plus 3x, right?
sorry.
It's alright. What do I need to do next?
Change the sign.
Change the signs. So this one turns positive, this turns negative. Have to change the signs because you're really subtracting it. These cancel. If you're doing it correctly, every step you're going to be canceling out that first one.
Oh.
Okay, if they don't cancel out, that means you didn't choose your number up here correctly. So x minus 3x,
Negative
2x plus 6. And then what times x gives negative 2x?
Negative 2.
Negative 2. So we get negative 2x, because you're negative 2 times x minus 3 plus 6. And since they match, when you subtract them, you get 0. So my answer is,
Next 6x
It's not
squared
0,
minus
John.
x
It's that
minus 2.
top one.
my answer is 6x squared minus x minus 2.
Look at that.
So there is your answer. All right.
How do we get the negative x at the top?
How do you get
Michaela Barnes in
This-
school office.
this
please.
right here?
Uh,
This turns, because you're asking yourself, what number or what variable, what times x gives you negative x squared? What times x gives you negative x squared? That's always how you figure out what number goes up here.
okay.
So the first one is what times x gives you 6x cubed.
Okay.
This one is what times x gives you negative x squared. And then this one, what times x gives you negative 2x. And if it divides out evenly, you've got no remainder, you get a 0. But if this last one doesn't match exactly, you end up with a remainder. Well, let's change our signs. We didn't change the signs. Okay, change the signs, and then it turns out, when it matches exactly, a lot of times I just don't bother changing the signs because I can see it'll just subtract and give you that number. All right, so shall we look at the shortcut today or not?
Today, yes, please.
Tomorrow.
Please. I'm gonna
Today,
do
tomorrow?
Today.
Tomorrow.
Only
Tomorrow, and then the other.
Unless you never get to that day.
Well,
The
I
other
like to be an
class actually won't
optimist.
be tomorrow either.
Oh.
Okay, so let's look at it today, and I'll do it again tomorrow.
Okay.
Okay, so there's a shortcut. For today, just watch and listen for a minute.
Don't write it down.
Don't write it down, we'll write it down tomorrow.
Dang.
Okay? What you're gonna do is you're gonna pick out some numbers from the division problem. This is the same one. Okay, so don't write it right now.
Okay.
Okay? This only works if the coefficient of this term is 1. It doesn't work otherwise. So since the coefficient of this binomial is 1, we can use this. And it also has to be x minus something. If it's a plus something, you change it to a minus negative. But this is x minus 3, so I can bring a 3 into my synthetic division. Okay? And it goes in this little box. This is why I'm saying you've got to, this is why I'm saying that we have to really pay attention to what we're doing. Then you look at the coefficients. You look at the coefficients of the numbers. My coefficients are 6, negative 19, 1, and 6. Okay, now here I'm going to draw a line.
Oh.
Like I say, it's a shortcut way. You've never seen it before. I bring down my 6.
Bring it down.
Then I multiply this number times 6. And I bring that up.
Whoa.
Okay? This number times 6 gives you 18.
I'm thinking
Then I
it's
combine these. Negative 19 and 18 is negative 1. Then I do this number times that number. And that gives you negative 3.
I'm about to go normal.
Then I bring these down and you get negative 2.
Ooh.
Then multiply 3 times negative 2, that gives you negative 6.
And then you get
Combine
0.
these, it gets 0.
Oh.
There's my remainder. Here are the coefficients of my answer. Here's my x squared term, 6x squared,
Where'd you get this? Oh, there it is.
minus 1x,
Wait.
minus 2.
Well, what happened to?
Okay,
Yeah, what did you
these represent, when you put these in here, they're representing place values with variables. When you do this little tricky thing,
tricky?
where you multiply and bring up, multiply, bring up, multiply, bring up, add the columns, you end up very quickly doing what we just did in long division and getting the same answer. Check that. Make sure that's the answer you just wrote for the long division one, right?
Yeah.
Yeah.
It is. How'd you get the X?
That's the one.
Okay. So that's how that works. It's the same problem. Same problem done, and you saw how quickly that was. It's a nice little trick, but we're going to have to really take our time so that you're able to do that. Let me shut off.